Hey guys, today I'm going to show you around my project, the Q learning on the game Space Invaders. To be mentioned that this Space Invaders is not the classic one. It's just a special version designed by me, and it will be a little bit different from the original one, and I'll talk about it later. So next I'm going to show you around my program, and I will explain to you how this program works and how this function works. So the first one, the configuration. It is going to set up the basic environment of the game. For example, the size, the screen size, the speed of the enemy, the player, and the bullet. And these are the very important one, the Q learning parameters. They are used for the agent to learn the pattern of the enemy, how they shoot, how they move, and learn the pattern to get the most the highest score, and avoid the bullet. Yes, that's it. So let's take a look on the second one. This second program is going to set up some loading to load some image resources, and for example, the background image of the game, and to define the drawing function, which will be used to draw the screen. And this one, the load font, it will load the font file, which I download from the internet. I especially choose a very interesting one, which I really like that. And this font will be used to print it in the screen. So in the game you will see that. So let's move on the fundamental of the whole program, and see in this Q learning program. In this program, it will be some definition of the whole Q learning function. So first, initiate the state, the Q table, and some action size, and so it will create this parameter, and then it will get some action. It will select the action using this application greedy strategy. This application greedy strategy is just something like that. The first, you open the game, and the agent will choose a random operation from this command, and the agent will just randomly move, or maybe move left or move to right away, or shoot. It will represent a really irregular representation, and it is totally random. Or you can see this, it will choose to select the optimal action, the greedy action. This greedy action is selected from the Q table, which will be trained on our text program. So this let's see this definition. Update queue table. It is used for update the queue table. For example, every time after you you process a training, you process after you complete an episode, and it will download, it will record the queue table data and write it into the data local file and load it, and then it will one day it will be need to use for the agent to learn. So that's it. And what about this definition, the decay application? This decay application has a value. I would explain how to explain, just like with the time goes by, once you open the game, you run the game, and as the time runs by, it will this value will gradually grow up, will increase. So so it will push the get action, this definition. It will push the action move to choose the most optimal action, the most greedy action, instead of random operation. So that's it. And let's take a look of the main program. This main program imports some Pygame, which is the necessary library, and you will need to download it. Without it, you cannot run the whole project. And so let's get on the all about this program. And this one, it will be initial the Pygame, and then load the resources, and it define the class player. It will create all the enemy, how they define how they move, how they shoot, and what about the bullet, and all about it. Just set it into a package and load it into the basic logic of this game. And besides, never forget the reset, because every time you lose or win the game will reset. And if you lose the game or if you win the game, the screen will show some text, some context on the screen. After this, we define the reset function, and here we have some function definition of the state, and detection of if the game is done, and the detection of if the player win or lose, just which step is going to take. And this is a basic logic of the whole game. And this definition will update the state of the object of the game. And here we have more definition. This one, it will calculate the reward. For example, if you shoot the bullet and you killed an enemy, you will get a score of 20. And if you were destroyed by the bullet shot from the enemy, you will get a punishment of a minus 15, and this will be an extra rule which I just designed it for prevent the agent just slide into one side of the screen, which is meaningless. And this part is a set up a rule to punish the agent if the agent just move around and just slip away into one side of the screen, on the left side or right side, and it will punish it. So I think this will help to let him know that there's no more hiding away. And here we have a collision check, and here we have a definition of draw, which is the graphic design. Yes, the graphic generation. Sorry. Yes, it is used for the generate the graphics so that you can see the game in your eyes. So move on. Let's see this two part. They are used for detect the condition whether the player win or lose the game, and in each proper condition it will put up some context on the screen. And here the last, you have a class explosion, which is some visual effect just when you hit by a bullet, or you shoot a bullet and hit the enemy, it will just explode, and that's all about the visual effect. And here let's explain how this training model work. The first initial the game, and it defined a loop of 10,000 times, which is to run 10,000 episode game, and every time after every episode, the program will automatically load or record the reward into the queue table and accumulate the data, so that those information will be used for the agent to learn the pattern. Yeah, that's all about, and will be update the queue table. And here is about it. And this test program would be more simple. It's just initial the game and run the game body, and just load the local file, to read the queue table, which is trained already, and it will read all the information, use the experience accumulated by the training model. After this process, I think the agent will be more will be smarter, and will be take some. He will need to he will be able to take some wiser operation. And so after explaining all about the program, let's see how to run the game and how these program, how are they work for, or what are they work for. So this main program, you run the program, and you open it, and you will enter a normal mode, which is still controlled by the agent. And you can see it's just very stupid, moving randomly, moving right and left, and shooting. That's about it. And there will be this. Still got 2 enemies to go. Not bad. So let's just close it and see how the agent will be trained. So now open the train function, run the program. In this condition, I accelerate the whole game. I just speed up the process, the training process, and it can save some time. So you can see here. You see the console. The console pattern here. It will demonstrate the information of the episode and the total reward here. Just as I said, it will record all the reward after every time a trained. And yes, that's it. It's all about it. All of those things just random, but the agent needs to learn the pattern of the enemy, how they move, how they shoot here. For example, the enemy would always start to move right away here and will shoot. So our player will always move right or move left to avoid it. When the player move left to avoid from the enemy, it can be safe, but in that context, you cannot kill the enemy, so you cannot get some score, and that's meaningless. So I set some rule, which is I just said formerly. So you can see he will just randomly move away and keep shooting. I said that about the total episode is 10,000, and it will take about 40 minutes to complete the whole episode. So to save the time, I will just close it and not let you to wait for it to complete the process. And I have already complete once the whole training and record the kill table, all the experience in the local file. So now the text mode can use it. So let's see, will that agent be more smarter? Will be more wiser? Honestly, it's hard to see. But at least I think still you can see some just like it. And my program just works. It works. Not that difficult, right? So that's all about my project demo. Thank you.